We're going to look at quadrilaterals on the coordinate plane in lesson 92. Now, once again, quadrilateral, just a four-sided polygon. And now we're going to put them on the coordinate plane, and it's just going to ask a couple of different questions in these examples, and we just have to prove it. So in example 1, it says, is quadrilateral ABCD a parallelogram? Okay. Sorry, got to sneeze. Okay, anyways, is ABCD a parallelogram? Gives us all these coordinates. How do we prove if it's a parallelogram? Well, the reason we know if two sides are parallel, okay, two sides are parallel if the slope is congruent. So we need to prove that opposite slopes are congruent. So I'm going to look at AD and BC. Now the slope formula is y2 minus y1 over x2 minus x1, because we're doing rise over run. So I'm going to isolate A, D, and then I'll put arrows for B, C, so I know what's different. So y2 minus y1, let's look at these two, all right? So in my coordinates of 1, 4 and 2, 2, okay, y of 2 is 2, y of 1 is 4, x of 2 is 2, x of 1 is 1. So my slope here would be negative 2 over 1. So the slope of AD, I can just say negative 2. So this slope has to be negative 2. So we're about to find out if it is or not. So looking at slope BC, all right, so my coordinates here are 5, 7 and 6, 5. So y of 2, I'll call it 5 minus 7 over x of 2, 6 minus 5. So that solves to be negative 2 over 1. So my slope here is negative 2. So as of now, I can say these are parallel. So that's half the battle. Now we got to do the other two sides, AB and DC. We got to prove that these two are parallel. So AB, the coordinate of A, 1, 4. B is 5, 7. So y2, 7 minus y1, 4 over x2, 5 minus x1, 1. Okay. Hopefully we understand how to do this formula, and this can all be quick. 7 minus 4 is 3. 5 minus 1 is 4. So this slope here is 3 over 4. And then now I just need to see if DC is 3 over 4. So my coordinate for D is 2, 2. Coordinate for C, 6, 5. So I'm going to plug in y2, 5, y1, 2, over x of 2, 6, minus x of 1, 2. And that solves to be 5 minus 2, 3 over 4. So the slope there is 3 over 4, so these two are parallel as well. So we can say yes, it is parallel, and then this is kind of the proof behind it. So that's how you're doing proving parallelograms. If it asks for a trapezoid, then you would have to prove, you know, that two opposite sides are parallel and that the other two opposite sides are not parallel. Because I know it does trapezoid sometimes in the book. But that is the same process of finding the slope. Now let's look at example 3. Looking at another kind of coordinate proof. It says, are these quadrilaterals congruent? All right, so are all 4 of the sides congruent? Well, in order to prove that, we're going to have to congruent. That's asking for the distance of each side. So we're going to need to solve by using the distance formula. So I'm going to try to find two sides that I think look like they should be congruent. I can find all 4 sides. You can do that if you have the program in your calculator. You can do that. But we can, the book draws it better than I do. So I'm just going to do some of the sides that the book says we're seeing if they're congruent. So the first one we're going to look at is EF and KL. EF and KL. Because in the book, kind of the shapes are a little rotated. Once again, the picture's better in my book and the book than on there. So we need to find the distance of both of those. So first, EF, so our distance formula, x of 2 minus x of 1 squared plus y of 2 minus y of 1 squared. So my coordinates for E and F would be negative 4, 6. And then F would be negative 1, 5. So I plug those in. X of 2 is negative 1. X of 1 is negative 4, so it would be a plus 4. Y of 2 is 5. Y of 1 is 6. So when I solve, it'd be 3 squared, that's 9. Negative 1 squared, that's 1. So this would be the square root of 10 for EF. Square root of 10. Now, let's look at KL. The coordinates for KL, K is 7, 3. L is 6, 0. So x of 2 will go 6 minus x of 1, 7. Y of 2, 0 minus y of 1, 3. 6 minus 7 is negative 1. Negative 1 squared is 1. 0 minus 3 is negative 3. Negative 3 squared is 9. So we end up getting square root of 10. So right now we know that EF and KL are congruent. So now we look at two other sides. So those are both square root of 10, square root of 10. Now let's look at two other sides. Let's look at DE and JK. DE, all right, so D is negative 6, 2. E is negative 4, 6. Let's find the distance between these two coordinates. So x of 2 is negative 4, x of 1 negative 6, so double negative is a positive there. Y of 2, 6, y of 1, 2. So negative 4 plus 6 is positive 2 squared, that's 4. 6 minus 2, 4 squared, that's 16. So this would be the square root of 20. So let's see if JK is also the square root of 20. The coordinate for J is 2, 6. And the coordinate for K is 7, 3. X of 2 is 7. X of 1 is 2. Y of 2 is 3. Y of 1 is 6. 7 minus 2 is 5 squared. So that's 25. 3 minus 6 is negative 3 squared. That's 9. So that ends up being square root of 34. These are not congruent. So since they are not congruent, we can say no, the quadrilaterals are not congruent. And you can you can go on proving all the other sides and whatnot, but once you know two sides aren't congruent, then you're good to go. So that's how you do lesson 92, a little bit monotonous, but nothing difficult math-wise at all.